We are going to talk today about how to find slope algebraically. So this is the beginning of our linear relations unit, and we will build upon that to look at linear systems and some analytic geometry. So you should remember slope from grade 9 math, but I'm going to go over it again and do some things that you may have seen before as well as some new skills. So slope, in case you forget, is the steepness of a line, and we can say that slope is equal to the rise over the run of a function. Okay, so in other words, we can think of it like how many units the line is going up and how many units the line is going over, and that's where we get the number for our slope from. We can use coordinates to determine the slope of a line. So obviously if we have the graph, we can count what the slope is. We can count the rise, we can count the run. However, we don't always work with graphs or want to have to graph something out. So if we are given coordinates of 2 points that we know are on the same line, we can find their slope. So first, I just want to go over for the coordinates of a point. We always write coordinates like this, x, y, okay, where x is the horizontal axis and y is the vertical axis. Okay, so we always list the horizontal coordinate first, then the vertical one, and x comma y, that's how we write coordinates. Okay, so if we want to find the slope of a line given 2 points, we can calculate it by this formula. So we use a little m, a lowercase m for slope, and this is equal to y2 minus y1 divided by x2 minus x1. Okay, so y2 minus y1, that represents the rise, what the change in the y coordinate is, and then x2 minus x1 represents what the change in the x coordinate is. So slope is equal to rise over run, and that would be given 2 points. And your points in this case would be x1, y1, and x2, y2. It doesn't matter which point you call which. We will look at an example in a moment, but that is how you find slope. Okay, so you're subtracting the y values, subtracting the x values, and then if you can simplify, you will do so. So this is the formula for slope of a line if we know the coordinates of 2 points. If we take a look at this graph or this Cartesian plane where we have 2 points plotted, we can determine the slope of the line that would connect those 2 points. So I have a red point and a blue point. I'm going to determine what the coordinates of them are, and then I can find the slope. So the blue point here, again, we always write our coordinates x, y. So this is the x-axis, this is the y-axis, and I'm going to go along my x-axis to see which coordinate we're at. So this is at 3, and my y value is 4. Okay, so for this blue point, I'm going to write my coordinates are 3, 4. And then if I look over at the red point up here, if I go along the x-axis, it's at -3, and then I'm going to go all the way up until I get to the point, and we are at 8. Okay, so for that one, my point is -3, 8. Now, I've got my 2 points here, and I'm going to use my formula, m equals y2 minus y1 over x2 minus x1 to determine the slope between the slope of the line that would connect those 2 points. So it doesn't matter which point you call x1, y1, which one you call x2, y2. It's just kind of a matter of preference. So I am going to call this one, let's say x1, y1, x2, y2. Okay, and I do that just so that I can, I like to write the labels below them so that I make sure I put the points in the right order, because it's important to make sure that when you are filling in your formula, if you're going to call this point your second point with the 2's here, you would do y2 minus y1, so 8 minus 4, but then you need to make sure that you start with this number for your x. Okay, so often what I see is people would write 8 minus 4 in the numerator, and then they might say 3 subtract negative 3 on the bottom, but that's not correct because you're mixing up the order. Okay, so you either need to go, like, call this x2 and this one x1, and do this y value subtract the red one, the blue subtract the red, or red subtract blue. Okay, so it always has to be the same order that you're doing those in. So we're going to write our formula here. M equals, I'm just going to write the blank one so you can see it again, y2 minus y1 over x2 minus x1. And I'm going to fill in what I know. So I'll have m equals 8 minus 4, and that is divided by negative 3 minus 3. Okay, so we're always subtracting in between our two numbers here. And if one of your coordinates is negative, like this one is, then you make sure you put that negative in there. Okay, so you'll see here, this again is my blue coordinate. Oops. Blue, and then my red ones are the ones that are in front. Okay, so it needs to either be both red as your first two numbers here, or both blue. Okay, so they're in the right order. So now I just need to simplify. So I'll have m equals 8 subtract 4 is 4. And then negative 3 subtract 3 is negative 6. Okay, so my slope is 4 over negative 6. Now, there's a few things we're going to do to make this fully simplified. So because this is a fraction, we want to check, is there anything that we can divide out of both the numerator and the denominator to make the fraction smaller in lowest terms. So both of these are even numbers, so we can divide them both by 2, which I'm going to go ahead and do. So I'll have m equals. Now, when you have a negative sign in either piece of your fraction, so it could be on the top, in this case it's on the bottom, you can just write it out front like this, right? If one of the values is negative, it makes the entire fraction negative. If they both are negative, then the entire fraction would be positive. So I like to write it out in front just because it makes it easier for me to see. So it's negative, and then 4 divided by 2 is 2, and 6 divided by 2 is 3. Okay, so my slope is negative 2 over 3. And again, this represents the rise over run. So when you are interpreting it, you can put the negative with the 2 on top, or you can put it with 3 on the bottom. It doesn't matter. You'll get the same thing either way. It's just important to note the way that your line is going to be moving. So obviously, if we were to connect the points, it's easy to just go to the graph and draw a line that will connect them, and we know what the line is supposed to look like and where it's supposed to go. But we can also use the slope to figure out what is happening. So typically, rise is going to be going up if it's positive, down if it's negative. For the run, you're always going to the right if it's positive, but if it's negative, you go to the left. Okay, so this could either mean down to right 3. Okay, you only make one of them negative. Or you could say up to left 3. Okay, as long as you remember that when a slope is negative, your line is always going to look like this. It's always going to be decreasing. Then you should be able to consistently draw your line how it should be. So a negative slope will always look like this. It's going to be decreasing, going down to the right, whereas a positive slope will always be an increasing line. So it would look something like this, going up to the right. Okay, so if you see a negative anywhere in your slope, you know it's going to be going down, and if you see no negatives, if it's just a positive slope, then your line's going to be increasing. Okay, so that's how we determine the slope algebraically. We said it's -2/3, and because we are given the graph here, we can also go ahead and double check that. So we obviously have the 2 points here, and we said they're on the same line, so I'm going to go ahead and connect these points with a line. I'm just going to extend it a bit further here so you can see it extends on either side. So when we're drawing any line, we always want to show that it continues infinitely in either direction. Okay, and you do so by just putting arrows on the end. And if we wanted to figure out from the graph what the slope is, I'm going to look and see, okay, how many units is the line going up or down by, what's my rise, and then what's my run. And you need to make sure that you pay attention to where your units actually are. So on this graph here, the darker black lines indicate my units, my whole unit. I'm going up by ones, and then the small, like the gray lines, are not really significant. They're just the sort of like in between units. So I'm counting how many, in this case, because my line's going down, I'm counting how many units is my line going down on the black lines and then over on the black line as well. Okay, so if I look at that, I'm going to see where my next point that lies on like an actual nice coordinate is. So if I look, that would be here. Okay, this is my nice point that lies right at the intersection of one of those dark black lines. So from my red point, I go down to here, and then I'm going over like this. Okay, so again, we said that our rise, if it's going up, it's positive, down, it's negative. So this would be going down 2, so -2 here, and then I'm going over 1, 2, 3, over 3. So my slope is down 2 over 3, and I could do it once more. I could go from this pink point down 2 over 3, and I get to my blue point, and then if I wanted to keep plotting more points, I could do the same thing as well. So the last thing with this example is we want to write what the equation of the line actually is. So you may or may not recall the equation of a line is given by y equals mx plus b. We said that m is the slope, right? So we already know that. And b is the y-intercept. So that is the point where the line crosses the y-axis. You will always have a y-intercept unless your line is just a vertical line going straight up and down, then it will not cross the y-axis. Otherwise, you'll always have one. So in this case, because we have the graph here, we can look and see where does the line cross the y-axis, and that's the point here that we plotted. It crosses when y is 6. Okay, so what we're going to do is we're going to create our equation. We know that slope is -2 over 3. We can see that the y-intercept is at 0, 6. Okay, so it's always going to, your x value will always be 0 for your y-intercept. So that means that our b value is 6. So if I wanted to write the equation of this line, I could say y equals -2 over 3 x plus 6, and I could easily use this equation to work with a linear system, which we will do later. You could use it to plot it on a graphing software on Desmos. You can use it to plug in any x coordinate to solve for the y coordinate, and it's just a nice thing to have algebraically to be able to represent the line that we have on the graph.